Day 414 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 802, find eventual safe states. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by a zero-index 2D integer array graph where graph of I is an integer array of nodes adjacent to node I, meaning there's an edge from node I to each node in graph I. A node is a terminal node if there are no outgoing edges. A node is a safe node if every possible path starting from that node leads to a terminal node or another safe node. Return an array containing all of the safe nodes of the graph. The answer should be sorted in ascending order. All right, y'all, so I could see how that may be a little bit confusing. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input graph, or before we get started, the first thing I want to make sure we understand what a directed graph is, right? So a directed graph meaning that each node corresponds to the index of graph. So since, as you can see, index 0 of graph is a 1 and a 2, that means node 0 points to 1 and it points to 2. Boom. Then we come to index 1. Index 1 is 2 and 3. That means node 1 points to 2 and it points to 3. Boom. Then we come to index 2. It has a 5. That means node 2 points to node 5, right? Boom. So on and so on. Index 3 means node 3. Since index 3 is a 0, that means node 3 points to 0. As you can see, it has the edge to 0. Boom. Similar with index 4 points to 5. So that means node 4 has an edge or points to 5. Boom, right? As you can see in the picture. Then 5 and 6, they don't point anywhere. So we have 5 and a 6 right here, and they don't point anywhere, or there's no outgoing edges. So now let's get back into the example. So in example 1, we have the graph. The input graph equals a 2D array of integers. First one being 1, 2, then 2, 3, then 5, then 0, then 5. Then the last two are two blank arrays. The output is an array of integers 2, 4, 5, and 6. The explanation says the graph is shown above. Nodes 5 and 6 are terminal nodes as there are no outgoing edges from either of them. Every path starting at nodes 2, 4, and 5 2, 4, 5, and 6 all lead to either 5 or 6. All right, y'all. So let's go ahead and break this down one step further. So a terminal node is a node where there are no outgoing edges. So as we can see, 5 and 6, they have no outgoing edges. Hence, they have a blank array because they're not pointing anywhere. They're two blank arrays for indexes 5 and index 6. That means nodes 5 and 6 are not pointing anywhere. So they makes nodes 5 and 6 terminal nodes. Then, but we don't want to return all of the terminal nodes. We want to return an array containing all of the safe nodes of the graph. Terminal nodes count as safe nodes because there are, I guess it counts as pointing to themselves since they're not pointing anywhere else. Then we stay at 5. Since 5 isn't pointing anywhere else, I guess it's like it points to itself at 5. Same with 6. If 6 isn't pointing anywhere else, I guess it's pointing to itself as 6, which is why we include 5 and 6 in our output. Now it says a safe node is a node is safe if every possible path starting from that node leads to a terminal node. So as you can see, 2 and 4 are safe nodes because 2 points to 5 and 5 is, as you can see in this array right, or this graph array right here, 5 is a terminal node. So that means 2 is safe, similar with 4. 4 points to 5 as well, and 5 is a terminal node, which means 4 is safe as well. It says, or another safe node, but in this example, they don't give any examples where it points to a safe node that points to a terminal node. So we'll just stick with the elements that point to terminal nodes, which in this case are 2, 4, 5, and 6, Once again, because 5 and 6, it's like they point to themselves, so include that. And 2 points to 5 and 4 points to 5. Since 5 is a terminal node, that makes 2 and 4 safe nodes. So I hope that made sense to y'all. Just remember, we want to return all of the safe nodes, which are nodes that point to a terminal node only, or another safe node. But in this case, it's just another terminal node. So 2 points to a terminal node 5, 4 points to a terminal node 5. 5 is a terminal node, so that's safe. And 6 is a terminal node, so that's safe as well. And that's how we got our output. Just in case that didn't make sense to y'all, though, that's what example 2 is for. Let's get into example 2, y'all. Now, example 2, they don't give us the picture graph, but it's okay. We'll be able to get through it because we know what a directed graph is and we know how it all works. So let's go ahead and take a look at example 2. So in example 2, we have the input graph equals a 2D array of integers, first array being 1, 2, 3, 4, second array being 1 and 2, third array 3 and 4, fourth array first array is 1, 2, 3, 4, second array is 1 and 2, third array is 3 and 4, fourth array is 0 and 4, and the fifth array is 5. Boom, the output is 4. Explanation says node 0, only node 4 is a terminal node, and every path starting at node 4 leads to node 4. So let's break this down one step further. So we know this is node 0 because it's at index 0. So node 0 points to node 1, node 2, node 3, and node 4. Boom. But as you can see, node 0 is not a safe node because it points to more than just node 4. If it only pointed to node 4, then it'd be a safe node. But it also points to node 1, node 2, and node 3, so it's not a safe node. As you can see up here with the safe nodes like node 2, or let's look at node 4. Node 4 only points to 5. It's not pointing to any other nodes that aren't terminal. It only points to a terminal node. Whereas down here, yes, it points to node 4, which is here, which is a terminal node, but it also points to node 1, 2, and 3, which are not terminal nodes, which means node 0 is not safe. Similarly to node 1, right? Node 1 points to 1, which is itself, I guess, and it also points to node 2. So node 2 is not a terminal node, as you can see right here. Node 2 points to node 3 and node 4. So as you can see, it points to node 4, but once again, it points to node 3, and node 3 is not terminal because node 3 points to 0, and even though node 3 points to 4, which is terminal, node 3 also points to node 0, which is not terminal, which means node 3 is not a safe node as well. Now that leaves us with our only safe node and terminal node, which would be node 4. As you can see, once again, represented by this blank array, that means it has no outgoing edges. And since it has no outgoing edges, that makes it a terminal node, but since it's itself, it's also a safe node, so we can include it in our output 4, similarly to how we included 5 and 6 in our output in example 1. So I hope that made sense to y'all with just returning all of the safe nodes. The safe nodes are the nodes that point to terminal nodes or another safe node. And that's how that works. Now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution's not that difficult to understand at all, so let's get started. Now, the first thing we're going to do is we're going to create a cache which will store the safety status of each node. True will equal safe, false will equal unsafe. So for that, we're going to come right here. We're going to declare a variable, call it cache. That's going to be a dictionary. We're going to set it equal to, it's going to be a dictionary : bool. Boom. And then we're going to put the parentheses outside like that. Then we're going to use a depth first search helper function where I is the current node and seen is going to keep track of nodes visited in the current depth first search path, which will help us to detect cycles. So for that, it's going to be a nested helper function. So inside the main function, we're going to say DFS open up the parentheses, I colon, int, comma, scene, colon. That's going to be a set of integers. So set less than int greater than, put the and we're going to set that equal to just a blank array. Come outside of that, it's going to return a boolean. Then we're going to open up the brackets. Boom. If we already know whether the node is safe, then we could just return it from the cache. So we could say if let cache equals cache square bracket I, then we could just open up the brackets and we can return cached, just like that. Now, if the node is already in the current path, then we found a cycle, and that means it's not safe. So we can say if scene.contains, open up the parentheses I, come outside of that, we're going to return false, just like that. Boom. Now we need to create a new copy of scene and add the current node I to it. So for that, we're going to declare, come right here, declare a variable called scene. We're going to set that equal to scene, which will allow us to mutate it. Come underneath that, and we're going to say scene.insert, open up the parentheses I. Now we're going to check if all neighbors of the current node are safe. If any neighbor leads to a cycle, the current node is unsafe. So we'll come underneath this and we'll say let result equal graph square bracket I dot, come outside the square bracket, dot all satisfy, open up the brackets, then we're going to say DFS, open up the parentheses, I colon $0, comma, scene colon scene. Boom. Now we're going to store the result in the cache. So we're going to say, come underneath that and we say cache square bracket I equals result. Boom. Now we need to return whether this node is safe. So all we have to do, come underneath that and say return result. But that's the end for the helper function, but we're not done yet. We still have more to do for the main function. So now we come outside of that helper function and we need an array to hold all the safe nodes, i.e. our output, right? As you can see, our output is an array. So we need to create that array to store those safe nodes. So for that, we'll declare a variable called result. And we're going to set that equal to an array of integers. Come outside of that, put the square brackets like that. Boom. Then we need to iterate through all of the nodes in the given graph. So for that, we could come right here and we'll say for I in 0 dot dot up to graph dot count. We're going to open up the brackets. And if a node I is safe, we're going to add it to the result. So we're going to say if DFS, sorry y'all, open that up. We're going to say if DFS, open up the parentheses, I colon I, come outside of those parentheses, open up the brackets, then we're going to say result dot append, open up the parentheses I. Boom. So remember, this is going to return a boolean. So when we say if, that means if this is true, then we return I. Then we need to return all the safe nodes in increasing order. So for that, we could just come right here and we can say return result, just like that. That should be all she wrote, y'all. Let's go ahead and give it a run. Ooh, okay. Oh, sorry. That should be seen, not synced. Sorry, y'all. Let's run it again. Let's run it again. Let's see. And look at that, y'all. It's accepted. Let's go ahead and submit it. Make sure it stays accepted after we submit it. Let's see. Okay, 26 milliseconds beats 54.05% of users. We could get those numbers up, but right now we're just worried about solving the problem that is presented to us. And I feel like this is a good solution for that, y'all. We It's an easy to understand solution, and we can use what we learn from this solution in future solutions, which is always important for our knowledge and understanding and learning process. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.